Hey everybody, welcome to the first chapter of Chem 121. We're going to talk about matter. We're going to talk about measurement. And remember, when you're a chemist, you study matter. You study how matter changes. You study all the things about matter. Well, matter is everything that has mass and takes up space. So basically, you study everything. Okay. So chemistry is the study of matter and how it undergoes changes. Here we have showing you the little particles in all substances. These little particles are either atoms, if it's an element, or they're compounds. And here you can see their arrangement makes differences. We've got ice, and we've got gas vapor, and we've got water, liquid. So we've got all three the phases of matter. But again, when you're a chemist, you study these little particles and how you can change them, the properties of them, all kinds of stuff like that. That's what you study when you're a chemist. Okay. When you're a scientist, and again, it doesn't have to be just a chemistry person. Of course, if you're a chemist, you're a lot smarter than everybody else because, you're in this class and you know what I'm saying. But anyway, whenever you're trying to solve a problem in science or any problem in general, we use a scientific method. Okay. The scientific method is a problem solving approach. There are steps to it. And if you follow the steps, hopefully you can solve your problem. The biggest thing to remember about scientific method is you have to have a problem. You see something and it's like, why is that happening? Or whatever. And from that, you do experiments and then you find patterns and you can actually end up with theories if you prove your hypothesis over and over again. Okay. So we're talking about matter. And again, if you're a chemist, that's what you study is matter. We define matter as anything that has mass and takes up space. So if you look below, we have different kinds of matter. We have all the exact same little particles. These are called atoms. And these are what make up an element. Okay, if you look at the periodic table, those are all the elements. Everything in the world is made up of those guys. There's 118 of them. There's a periodic table in your book. Use it a lot or get one run off or whatever and have one because the periodic table is like your best friend in chemistry. It tells you lots and lots and lots of stuff. Okay, here you've got, if you take two of the same and put them together, now you don't have an atom anymore, you have a molecule. Okay, you can have, this is a molecule of an element. Okay, there's 7 different elements that when they're pure, they're like this. Hydrogen's one, oxygen's one, nitrogen's one, and the halogens like chlorine, bromine, iodine, those guys, what'll happen is they won't stay individuals. They'll go like this. And here's molecules of a compound. Okay, you can see we've got 2 different elements here. We've got the green element and the purple element. Okay, and now we have a mixture as well. Here you take a couple of these, couple of these, couple of these, and you put them all together, and now you have a mixture. Okay, so these guys over here, when they're all the same, are called pure substances. When you mix things up, which makes sense that it's a mixture, you've got that. So when you study matter, you study all these different things. Okay, here's some examples of different kinds of matter. Sorry about oxygen being covered up here. I'm not sure where to put myself, so I stay out of the way. But here's oxygen, and oxygen's a diatomic element. Any of you guys that have ever worked in health careers or health hospitals or whatever, you always hear oxygen called O2 because there's always 2 of them together. Here's water. There's your 1 oxygen and your 2 hydrogen. I think most people know that water is H2O. Here's carbon dioxide, CO2. Okay, here we got ethanol. Ethanol is the alcohol that makes your weekends a little bit more fun, if you know what I mean. Ethylene glycol, if you don't know what that is, that was for a few years the wife's favorite ways to poison their husbands. First it was arsenic, but they got onto that. And then for a while it was antifreeze. This is antifreeze. And then you can see aspirin. Aspirin's fancy name is acetylsalicylic acid. So you can see we're getting more and more complicated as we go. We can have huge molecules like DNA. DNA is made out of millions of these, so it just depends on. But atoms are the building blocks. All of these break down to individual atoms. Each element has the same kind of atom, so all oxygen atoms look the same. But if you compare an oxygen atom to a carbon atom, they won't be the same. So each element has its own individual type of atom. And if you want to combine atoms to make molecules, now you have compounds. Okay, so when you're talking about chemistry, everything's made out of elements. If you break elements down in their little tiny parts, they're atoms. You can put atoms together, and in this case, we only have oxygen, hydrogen, and carbon. Okay, they're about 90, I think it's close to 95% of all things are just made out of oxygen, carbon, and hydrogen. Those are organic compounds. Okay. Okay, so states of matter, you guys have probably talked about states of matter since you were in elementary school. Really, when we talk about states of matter, we talk about the particles and how close are they? They determine a lot of things about what they call the phase that they're in. Okay, so when we're talking about particles, really what we're doing is either talking about atoms or molecules. So here we have a crystalline solid. A solid, you can see they're very stringent, they're very rigid. Okay, they're very orderly, and that's why you can't change the shape of a solid, or you can't, change its volume or whatever. So this is a solid, and again, it's because the particles are so close together. Now, some people think that these particles don't move. They do, just a little bit. Okay, everything moves until you get down to what they call absolute zero. At absolute zero, everything is frozen. I think it's negative 273 degrees Celsius. Hopefully we never get that cold. But anyway, there are some solids that are a little different that will change their shape a little bit. They're called amorphous, like wax and slime, everybody's favorite thing if you're a little kid. They're a little bit different solids, but it's because of the arrangement of the particles. And then when you get to a liquid, you spread them out a little bit, little disorder to them, not a lot, but a little. And because of this, these particles can slide across each other, and that's why liquids pour. And then you get to the gases. And the gases, the particles really don't want to have anything to do with each other. The farther apart they can be, the better. But you can do things to these particles. You can squish them, like by increasing pressure, increasing the temperature, you can get them move around faster. There's actually a whole chapter that we'll talk about with gases because they have special laws because they're kind of unique. These two guys are very similar to each other, not so much with the gases. Okay, when we talk about matter now, all matter, okay, and like I said, matter is everything you touch, feel, or feel, which is almost everything. And sometimes I'll ask people, okay, tell me something that's not matter. And sometimes people will tell me air. Air is matter, you guys. And you're like, well, I can feel it. Ever been outside on a windy day? That's air. So air is matter, okay? So when you have matter, anything, you look at it and you say, okay, is it the same throughout? Does it look the same from top to bottom? If it does, oops, better go the other side. If it doesn't, then it's called a heterogeneous mixture. Hetero means different, okay? If it is the same throughout, if it looks from top to bottom, it looks the same, then it's called either, you can say homogeneous or homogeneous. I've heard it both ways, okay? So if it is the same throughout, does its composition vary? By that I mean, like if I'm talking pure water is H2O. It's always 2 hydrogen, 1 oxygen. If I'm talking tap water, my tap water and my faucet from here in Botno is way different than your tap water in Belcourt. You wouldn't think it is, but it is. There's a lot of different minerals. There's a lot of different things that come from the soil in your water. So it has variable composition. Okay, so if it can vary its composition, it's a homogeneous mixture, which they also call a solution. Tap water is an example. If you make Kool-Aid, okay, Kool-Aid, you can put a little bit of sugar in there. You can put a lot of sugar in there. It depends on really what you want to do. Okay, if it doesn't vary, if it's always 2 hydrogen and 1 oxygen, or like salt is sodium chloride, NaCl, it's always 1 sodium, 1 chlorine. If it never changes, if the composition, it doesn't matter where you get it from, it's always the same, then that's a variable composition and that's a pure substance. Okay, it can be separated into, so if it's a pure substance, if it can be separated, it's an element. If it can't, I mean, if you have a compound, you can, sorry, I said that wrong. A compound you can break down into smaller substances. An element you can't. An element is as small as you get. A compound like hydrogen and oxygen, water, you can take and put electricity through water, it's called electrolysis, and you can break it down into hydrogen gas and oxygen gas. But now you've got the hydrogen gas and oxygen gas, you can't break them down anymore. Okay, so all matter is either a mixture or a pure substance. The 2 pure substances are elements and compounds. The 2 types of mixtures are heterogeneous, not so well mixed up, and a solution or homogeneous, well mixed up. Okay. All right. So when we talk about matter, we talk about its properties. Okay. And matter has two types of properties. It has physical properties and it has chemical properties. Physical properties is what you can see. You can observe these and you're not going to change it to a new substance. So like if I'm talking about water, water is clear, its boiling point is 100, its freezing point is 0, its density is close to 1. If I have a glass of water, I can figure out its mass by putting it on a scale. I can figure out what volume by putting in a graduated cylinder. All I'm doing is basically telling you what it looks like, things about it. Okay. If it's a chemical property, now I'm saying, okay, this is how I can change it into a new substance. If I'm still talking about water, if you pass electricity through water, you can break it down into hydrogen gas and oxygen gas. Okay. And you can only observe chemical properties by changing it into a new substance. A real common one is flammability. Will it burn or not? If it corrodes, if it rusts, okay? And a big one is if ever you see reacts with air, reacts with water, reacts with acids, any reacts with, you know that's a chemical property because you're telling how it's changing into a new substance. Okay? When you talk about types of properties, they have intensive, and these are both physical, but intensive and extensive. Intensive means it's independent of the amount. For instance, if I find the density of water, it's right around 1. It doesn't matter if I do a small cup of water or if I do a pool full of water. The density is 1. So it doesn't matter how much I have. Same with boiling point. When you boil water, whether you boil a little bit or you boil a lot, the boiling point is 100. The color of water doesn't change if you've got a lot or a little. So if it doesn't matter the amount you have, that's called an intensive physical property. If it does matter, like for instance, its mass. Well, if I put a cup of water on the scale, it's going to weigh a lot less than if I put a gallon of water on the scale. So those are going to change. The same with volume. And what they mean by energy, if you react it with something, you're going to get a lot more energy from a big amount of substance than a little amount. So these are the two types of physical properties, intensive and extensive. Okay. Then along with properties, we have changes. Okay. You can have a substance go through a physical change, and really all you're doing is changing it into a different form. For instance, if I take ice and I melt it, and now I went from a solid to a liquid, but it's still water. That's a physical change. Or if I change the temperature of something by heating it up, or any of those kinds of things. If you take a piece of paper and you tear it in half, it's still paper. You change its shape. So if you start with and end with the same substance, you know it's a physical change. A chemical change, you're going to end up with a new substance, and your new substance is going to have different properties. Here they have combustion. Combustion means to burn things. Okay. If you take a log, it's summertime and you're having your campfire and you throw a log on there, and when you're all done burning that log, if you've done a good job, you're not going to have anything left but ashes. Those ashes are a different substance now. Okay. So if you start with and end with different substances, you know it's a chemical change. Okay. An example is if you take hydrogen gas and oxygen gas, two gases, you combine them, they will form water. And water is way different. It's a liquid, and it's way different than oxygen gas and hydrogen gas, which are very, very flammable. Obviously, water isn't, because that's what we use to put out the fires. Okay. So when you're talking about that, when you're doing a chemical change, you're doing a chemical reaction. And this is the one I talked about. Here's hydrogen gas, here's oxygen gas. Okay. These are diatomic elements. There's always two of them together. Okay. Hydrogen gas is extremely flammable. It was what was in the Hindenburg, if you've ever watched the video of the blimp that blew up. It was very, very flammable. They don't put hydrogen gas in blimps anymore. They use helium because helium is unreactive. It took them a little while, cost a few lives, kill a few people, figure it out. Anyway, you got hydrogen gas, you got oxygen gas. Gas, ice, oxygen, same thing, diatomic. Put them together, you have water. This is definitely a chemical change because water is nothing like the two things that it came from. Okay? So that's how, when we talk about a chemical change, you start with different things than you end up with. That's how you know. If you start with and end up with the same thing, it's a physical. If you end up with different things, you know it's chemical. And now I'm going to be done with this lecture, and there's going to be some questions for you to do in your module. So good luck, you guys. And if you have any questions, let me know.